Hello, this is my Digital Solutions final. I've chosen the temperature fan as my assessment piece, and this is the mind map around it. So we have three main staples for the mind map. We have functional requirements, non-functional requirements, and constraints. First, we're going to go with constraints. So there's user environment. So this is the type of environment, like it could be used in fridges or computers to cool down CPU. Is it hot enough to be needed? Yeah, it's not that hot enough. Sometimes there can be cold as well. But no, sometimes it is hot enough. User technical skills. So you don't need many user technical skills to be able to set up and then use this device. It's pretty easy to use. You just plug it in and it will do its thing. Under constraints, we also have developer environment. The equipment was provided and readily available. We had to use our design skills for a 3D printing of a fan holder and the wires. The programming skills was probably the biggest part that we needed to be doing, because without it, our entire project wouldn't work. For the functional requirements, there is data and core modules. So under data, it has existing organizational data. This means that for a big company like Vita or Cinex, means that they already have stuff like this in their CPUs, which cool down the fan when it gets too hot. Then there's data structure and formats, which means we need to structure our data in a way so that it's not plagiarism. Then we have data types and structures. So this is sort of like the last one. We have to structure our data types so that they fit in with everyone else's. And then we have new added data. So when the data is added from the temperature sensor, which is an input, it will be used in real time to tell the fan and the LCD what to do. So if there was a 25 degrees Celsius that came through from the temperature sensor to the fan and the LCD would read the value and go, I'm going to display this, and it will display 25 degrees Celsius on the screen. Then the fan would turn itself on to cool down the CPU. Then there's core modules. So there's not many menu options with our project, because it's mainly used for cooling down or things that are too hot, which can only vary from like CPUs to fridges. Yeah. Then there's managing visual displays. So we make our temperature fan look as good as possible, so we have nice chords and everything as in aesthetics. And then there's calculations with data. So the code runs through the degrees Celsius. It reads the temperature in the room and then gives us the degrees Fahrenheit. So we've set it up on the code so that it turns it into degrees Celsius for easier reading. Then we have non-functional requirements, which is like aesthetic. So in aesthetic, it's all about how the 3D printed is designed, like how the fan stand is 3D printed and designed, how nice it looks, how the cables plug in all straight and nice and neatly. It's about that. And then there's the economical standpoint. So will we have the budget? Our budget is probably about $70 to $100 of kit. And then we have the time limit, which is where will we get it done in the time that it takes to set it up. Then we have legal, where copyright, so like brands like Nvidia and Cisco, like I've mentioned before, will they have stuff exactly like our stuff and try to infringe laws against us. And then for legal reasons, we have to put a fire hazard warning on the front of our product or design. So that's the mind map done. Now we have the evaluation criteria. So the temperature fan is designed for when the temperature sensor overheats. It sends a series of commands to the board. It tells the processor to turn on the fan, which cools the temperature sensor down. The project labeled temperature fan works in the following steps. 1. The temperature sensor gauges the temperature in the air surrounding it. 2. If it picks up the temperature below 20 Celsius, it activates the monitor connected to the breadboard to spin the fan attached to itself, cooling the temperature sensor. When the temperature in the sensor cools to above 20 Celsius, it turns the fan off. In this situation, the outputs are the motor, which is connected to a plastic fan, and the LCD, because they take values from the temperature sensor and use them as executables. For example, when the temperature sensor reaches the temperature of 20 degrees Celsius, it sends a command to the motor to start spinning, and sends a command to the LCD to display the temperature in the room. This is our user interface. So here we have the LCD connected to the Arduino board and the breadboard, and the temperature sensor, which is connected also to both, and the motor, which is only connected to the Arduino board. The parts we used for this assignment was an LCD, a motor, a plastic fan, and a temperature sensor, and a lot of wires, female to male and male to male. The LCD is a digital screen that takes values from inputs and displays them on the screen. The motor is an electric motor which receives inputs that controls the speed at which it spins and when it spins. The temperature sensor is basically a digital thermometer. It is classified as an input because it collects the data, in this case the temperature, and sends the information to other outputs. Data. In this project we are collecting temperature from the surrounding air. The data will determine whether the fan is turned on or switched off. The data is measured in Celsius, which is converted from Fahrenheit. This is because when converted into Celsius, it is easier to read and understand. It then displays the reading in Celsius on the digital screen and refreshes itself every second. This is sort of a makeshift flowchart. So the temperature sensor turns on. It checks if the temperature is lower than 20 degrees Celsius or higher in our case. If not, then it will check again in another second. If it does see a temperature lower than 20 degrees Celsius, it will turn on a motor, which will run the fan. The fan will cool down the temperature, and then when the temperature is over 20 degrees Celsius, it will turn off the fan. If it doesn't, then it will check if it's lower than 20 again, and then turn it off. If yes, then it will go back to running the fan. This is our code, and I only know a bit of it, so I know that this is the LCD print, the delay, the LCD clear will, so the LCD print displays a value on the LCD. The delay will create a delay of 1 second between each time it was refreshed. The LCD clear clears the LCD screen. Either that or it writes on the, it tells the motor to turn on, then it spins it at a certain speed, and then yeah. See here, this is our temperature sensor working. So when Sam covers his hand over it, the value of the degrees gets higher. So the temperature rises as he puts his hand in. As the temperature rises, the fan activates, and it is meant to cool down the CPU, but since the CPU is on the other side, it doesn't. But yeah, this is it running out of power. So some design faults is that we have to apply some capacitors so that we'll have more power, or lower the fan speed so that it doesn't run flat like that. So yeah, that's our assessment.